In the next two section worksheets, we're going to talk about factoring something called a quadratic trinomial. So this is, of course, a trinomial, and its factored form is going to be the product of two binomials. So essentially what we're doing is we're learning how to undo the FOIL method that we learned in the previous chapter. So remember, the FOIL method is a way to remember the steps when you're multiplying two binomials, okay? So that's going to be one of the first things we do in this worksheet. So first, you need to know what a quadratic trinomial is. We're going to deal with quadratic stuff quite a bit in the form of trinomials in this chapter, and then later in the form of equations or functions in a future chapter. So a quadratic trinomial is a trinomial of the form ax squared plus bx plus c such that a is not 0. Okay, now we do have a little bit more here. Okay, a, b, and c are real numbers. Okay, so that means they could be fractions, they could be decimals, they could be integers. We just need to make sure that a is not equal to 0. What is making this trinomial quadratic is this x squared term. Okay, if the highest degree term is degree 2, that tells you have a quadratic, whatever, trinomial equation function. Okay, if a is 0, that x squared term becomes 0 and it's no longer quadratic. Okay, so we can have a, b, and c be any real number. We just have to make sure a is not equal to 0. Okay, so quadratic trinomials are considered second degree polynomials because the highest degree is going to be 2. That's what makes it quadratic. Okay. Please note, and this is going to be a big part of dealing with quadratics, a, b, and c are fairly consistent. A is always the coefficient of the squared term. B is the coefficient of the linear term, or just x. So the linear term is going to be the term that has the variable to the first power, so just x. And then c is the constant. So a is the coefficient of the squared term, b is the coefficient of the linear term, and c is the constant. And again, a, b, and c are going to be a big part of what we talk about in the next two worksheets. Okay, now just as a quick review, let's remind ourselves of the FOIL method. We talked about this very briefly in the previous worksheet, but let's officially remind ourselves of the FOIL method. So the FOIL method is used to multiply two binomials, very specifically two binomials. FOIL is basically an acronym that tells us the order to multiply the terms in the two binomials. So F stands for multiply the first terms in each binomial. O stands for outer, which means multiply the first term of the first binomial and the last term of the last or the second binomial. I stands for inner terms, so the two terms in the middle, so the last term of the first binomial, first term of the second binomial, and then finally L stands for last, which means multiply the last terms in each binomial. So if we had something like A plus B times C plus D. The first terms would be A and C. Those are the first terms in each binomial. The outer terms would be the terms that are quite literally on the outside of this product, which would be A and D. The inner terms are the ones on the inside of this product, which would be B and C. And then the last terms would be the last term of each binomial, which would be B and D. So it just gives you a way to remember what to multiply when. For me, it's easier to think of this as just distributing twice. I take each term in the first binomial and fully distribute them through the second binomial and then simplify as needed. Okay? So for example 1, we're just going to find each product. We're just going to practice the FOIL method. And then I did add an extra part. What do you notice when you multiply? So we'll talk through that in just a bit. So for part A, we have x plus 7 times x plus 4. We're going to go ahead and find our products. We take x times x, which is x squared, x times 4, which is 4x. And then we're done distributing the x, so we're now going to distribute the 7. So 7 times x is 7x, and 7 times 4 is 28. So I simplify, and I get x squared plus 11x plus 28. Now let's notice a few things. We have, I'm going to underline in red and green. So let's look at this 28. How did I get 28? Well, I multiplied my 7 and my 4. That's easy enough. And then notice here, I also have 11x. Well, how did I get 11? Well, I took my 7 and I added it to my 4. Okay, that's not an accident. So notice 7 plus 4 is 11. And 7 times 4 is 28. And those are two really important numbers in the final trinomial that we get as our product. Okay, so let's look at the second example. I'm going to take x times x, which is x squared, x times 6, which is 6x. I'm done distributing the x. Now I'm going to distribute the negative 5. So negative 5 times x is negative 5x. And negative 5 times 6 is negative 30. We simplify, and we get x squared plus x minus 30. But let's talk about a couple of things. So let's look at, we'll do green first. Let's look at this x right here. Well, I got x by simplifying 6x minus 5x. So basically, if I take this minus 5 and I add it to this 6, I get 1. And that becomes this coefficient here. So negative 5 plus 6 equals 1. Okay? Let's now look at the green or the red part. So negative 30. Well, how did I get negative 30? I got negative 30 by multiplying negative 5 and 6. And that's not an accident. And that's going to be something really important that we have to look at when we start factoring. So essentially, when we start factoring, let me go back to black ink. When factoring, we start here and go here. So we're just working backwards. We're basically going to be doing the FOIL method in reverse when we talk about factoring these quadratic trinomials. So make sure you're really, really good at foiling. Make sure you're kind of really good at understanding where these coefficients of x and then the constant come from, because that's going to be a big part of what we do in the next few examples.